Hello everyone. So today I am back again with the hardest and final topic on sliding window, which is prefix, suffix plus sliding window. This is actually very hard topic of sliding window. That's why I put it the last. Okay, it's mainly asked in top MNC companies. I could say in last round of your tech interviews, mostly. Okay, last round of your tech interviews. Fine. So this is the prefix suffix plus sliding window. Actually, very hard topic. As in when we go through the explanation, please be with me to understand it very clearly. Fine. Okay. So what is the use case of this type of problems? When we need to use it? So when the question asks for finding two non-overlapping subarrays. Okay. In some way you will get that. Okay, I need to find two non-overlapping subarrays or substrings satisfying some condition on k. Okay, and that too minimum length or maximum length depending on the question. It could be minimum length of those two non-overlapping subarrays, or it could be the length could be given the fixed, then that could be the case of the fixed size sliding window on some condition k. Okay, so first thing which you need to do is, first step is, you need to make a sliding window function. Now what this function will return? Make sliding window function. This function will return one answer vector. This function will return one answer vector. Okay, just be clear until this. This sliding window function should be simple sliding window function only, whatever we are doing until now. Just one change you need to do. Every time, every time you update answer of j, you need to compare it with previous value. That is answer of j minus 1. So if at all it is minimum, if minimum, then answer of j needs to be minimum of j comma j minus 1, and if maximum, then answer of j needs to be maximum of j comma j minus 1. This you need to take care of. Okay, this is the only one thing which you need to inculcate while doing the sliding window function for prefix suffix. Now another step, second step, which should be implemented in main function. Implemented in main function. Okay. You need to make two vectors. One vector of int prefix, where you will call your sliding window function, which we have made above. Okay. We will call our sliding window function with this nums array and this k. Now we need to perform the same for the reverse array, which we call it as the suffix array. So we will reverse our actual array. Sorry. We will reverse our actual array and we will perform the same thing. As I told you, this sliding window will always return what? An answer vector. Now, what this answer vector consists of, I'm coming at the later stage. Okay. So this suffix, you will call again this sliding window function with reversed nums vector. And if you got this suffix, you will again reverse it. You will again reverse it because you have got it in the reverse manner as you have reversed the nums and find it. So you will reverse it again, reverse it back to get the correct answer. So this is your suffix array, this is your prefix array, and this is your suffix array. Clear? Now we will move further. Now first thing, what does this answer of j means? So answer of j means the subarray ending at j, whatever is given, minimum or maximum value, whatever is asked in the question, minimum or maximum value of condition, whatever is given, for subarray ending at j. Now when we are calculating for the prefix part, we are simply sending the nums array as it is. So this is valid case, like answer of j is the minimum or maximum of condition for some subarray ending at j. That is correct. Now we are reversing our nums array. Now what we are doing, we are reversing our nums array. Let's say this is your nums array 3 4 5 1 2. Okay, and you got answer of 2 as 2. Okay, some random thing. This means that subarray, the 2 is the value of your condition, answer of your condition, where subarray is ending at 2. I didn't know about the starting point. Okay, for the prefix part, I'm telling this answer vector what it stores, that's I'm telling you. Now you are reversing it. So if you are reversing it, the question becomes 21543. Okay, and now if you got the answer of 2 as 2, that means here also the same thing, ending at index 2, or not 2, let me consider 1, so that 2 is because middle index. So I am telling that answer ending at 1 is 2. Answer ending at 1 is 2. It might have started from somewhere. It might have started from somewhere. So this is what it has covered. Ending at 2, ending at index 1, that means something previous one and then ending at this first index. So either 2 1 or just 1. Okay, so either 2 1 or just 1 will be either this one or this 1 2. So for the original nums, this is what, this is starting at index j. Because I have reversed it, this means that this is starting at index j. When I'm calculating it, we do not need to do any change. This function remains generic, but we are reversing the nums array and passing it. This means that this actually means for suffix array, this means for original array, for original nums, this answer of j represents the subarray starting at j, starting at j for suffix part. Okay, so this is for prefix, and answer of j indicates some minimum or maximum value on condition k for subarray starting at j. This is for suffix part. Okay, I didn't need to do anything on the main function. I'm again repeating because I'm reversing my nums array. Okay, see here ending at index 1. This means that this from for here it's starting from index 1. So it means like starting at index j, and for prefix it's normal ending at index j. Clear? I hope I'm clear. So now let's say our answer vector is something like 2 3 4 1 5. Okay, this is for prefix array, and for suffix array it's something like 3 4 1 5 2. Okay, so this 2 means ending at 0, this 3 means starting from 0. Okay, but always the question will be mainly for non overlapping subarrays. So now we need to find two non overlapping subarrays and we need to calculate the maximum answer possible. So always we will do what, we will run one loop in our main function after calculating this prefix, suffix, and reversing the suffix. Why reversing? Because we have calculated from the opposite side. Here actually answer of 1 is 2 means answer of 1 is not index 1, it is actually index 5 minus 1. Okay, 5 minus 2, which is 3. This should be for index 3 because 1 is here at index 3, 0 1 2 3, right? But I have got here for 1, so I need to reverse it. Because I have reversed it and calculated for suffix part, I need to reverse it again when I'm calculating the correct answer. We'll go through the examples and you will get it very clearly. So every time what we need to do, we need to maximize this. If we are taking I part of prefix, that means some subarray ending at index I, then we need to start from I plus 1 for the suffix array, because suffix array indicates subarray starting from I plus 1. So ending at index I, starting from I plus 1. This two we will do the summation and we will check what is the maximum or minimum as asked in the question, maximum or minimum. And this way we will find two non-overlapping subarrays, one from some index to I and another from I plus 1 to some index. Okay, so before I move to this question, let me just go through the template of this. Okay, so we will have two functions. One is our main function where we will be given nums and k, some condition. Okay, and another is sliding window function where we will return this answer vector as I told you. So the sliding window function here also will pass this nums and k function, k value. Okay, So we will have one I0, J0, one answer vector of size n is the num size. Okay. Now what we will do, while j less than n, the same case. Okay. Considering it to be the maximum. So if condition satisfies, okay, if condition satisfies, then there could be two cases. If j minus 1 is greater than equal to 0, I always need to compare, right? So then answer of j needs to be maximum of previous one or this current, which is I'm storing length. Okay, maximum length if they have asked for, then j minus I plus 1. Else, if there is nowhere, so if j is itself 0, then I just need to put it. I didn't need to do anything else. What I'll do, else your while case. So while condition greater than k and I less than equal to j, greater than k or less than k, that we have discussed in a previous video, you will get from the question. Okay, whether you need to put greater than k or until less than k. So here what you need to do, you need to slide the window. So anyways you will be doing here the calculation part, okay, like summation or anything. So slide window with reverse calculation. Okay, and I plus plus. If after coming outside, if condition remains, if condition satisfies or equal to k, let's say, then the same thing you need to do. If j minus 1 is greater than equal to 0, then answer of j is this, otherwise this, and all those things. We will do j plus plus. Here also we need to do j plus plus. Okay, after coming out, after coming out we need to check. So we have checked two conditions. Let's say it was asked that sum should be equal to k. Okay, we have checked sum equal to k, we are doing this. While sum remains greater than k, we are sliding window. If sum remains equal to k, we are comparing it with the previous one and modifying it. If previous is there, then comparing and modifying. If not there, we are directly modifying. But what for condition less than k? Let's say here we have kept it greater than k only. So until if condition remains less than k after coming out from here, okay, or if we are not at here only, let's say for the first value itself, the first value of the nums is, let's say, 1, and your target sum is 3. So sum remained less than k, then what you have to do, there also you need to compare. I have told you, compulsorily we need to compare it with the previous value every time, every time. So coming out of the here, we need to check if if j is less than n, and why j less than n, because we are doing j plus plus, it might have become greater than equal to 1. Okay, and our j minus 1 has greater than equal to 0, then we will just compare it. Okay, whether it minimum or maximum, anything, we'll compare it with the previous one and update it. This is specifically for condition less than k. Here less than k, because for greater than k we are anyways removing and sliding window. And if condition satisfies, we are doing. But what if it is not satisfying? Okay, so we need to do this generally, generic case, so that it updates every time. I hope I'm clear with this. Okay, and now for main function, simple, we will return this answer vector. Okay, we'll return this answer vector. Now for the main function, what we will do, we will have one prefix array. Okay, which is nothing but this sliding window of nums and k. We'll reverse this nums, and we will find one suffix array, which is again sliding window, and we will again reverse this suffix array also. Now if we want to do minimum or maximum, depending on that, we'll go until n minus 1, because if we take prefix until I, so that is some subarray ending at I, then we need to start from I plus 1. So we will do every time prefix of I plus suffix of I plus 1. Now I hope you are uh, clear. Okay, and we will return this answer array. Fine. Okay, so this question is similar like that only. We need two non-overlapping subarrays. Okay, the sum of both those subarrays needs to be equal to target for both non-overlapping subarrays. Okay, the sum needs to be equal to target, and size of both subarrays needs to be as minimum as possible. Here I wrote the template considering the maximum, but here they are saying that size needs to be as minimum as possible. Fine, let's just dry run on the above template what we have wrote. So I will have one sum variable as 0. I'll go. So I came to index 1. Okay, I came to index 1. Let's just have it. Okay, so we are at index 1, we are at index 7. Our sum is 7. So sum is 7. Our answer vector will be answer of 0. Condition is satisfied. So anyways, j minus 1 would not be present over here. J minus 1 will be minus 1 at this point. It's not greater than equal to 0. So we will simply do j minus I plus 1, which is nothing but 1 length j0 I0 plus 1. Okay, moving forward, j plus plus 7 plus 3 is what? 10. So while this sum remains greater than 10, we are subtracting it from this 7 part. So let's say I'm subtracting it. Okay, so we have subtracted 7. I came to I came here at 3 and j is also at here. Okay, so now my sum is 3. We came out of this loop while loop while sum greater than k and I less than equal to j. We have done this. Now condition satisfying? No, condition is not satisfying, but still we need to do answer of j as maximum. Why? Because we are storing correct answer only in every answer vector. Okay, so answer of 1 is what? Answer of 1 is what? Any subarray ending at I or until I can say, not exactly ending at I, until I. If I take any subarray until I, so this is the subarray 7 comma 3. Okay, from this I can choose one subarray. That's what my correct answer vector represents. So here answer of 1 is what? Maximum, or sorry, minimum of this is 1. And initially, as I need to do minimum, I will initialize my answer vector with 1e9 as max as possible. So my previous value of answer of 0 is 1 and current value at first index is 1e9. So both of this answer of 1 will become 1. So I could have one length subarray until first index. I could have one subarray until first index. Okay, if I take from 0 to first index, I can make one subarray. Which subarray? 7. 7 subarray. This subarray I can make. So it is not exactly ending at I. Whether I could find or length minimum or maximum value of condition for subarray ending at j, I can correct that. Okay, it's not ending at j. It's minimum or maximum value or length of condition for subarray until j. Until j doesn't means includes j. Any subarray until j, is it possible or not? Okay, and this is starting from j. Starting from j, minimum or length starting from j. So it doesn't mean that j needs to be included. The jth index needs to be included. No, it doesn't mean that. It means that can I make any subarray? Yes or no? Okay. Now answer of 2. Okay. So now my sum is 3. Fine. So 3 plus 4. J is at 4. 3 plus 4, 7. Okay. Sum has become equal to target. So what could be my answer of 2? Now my j minus 1 is this. Minimum of j minus 1 is what? 1. Okay. Minimum of answer of 1 is what? 1. And current is j minus I plus 1 is 2. Which length? This 2 is 3 and 4. So now it is considering 3, 4. But until now I have found minimum as 1. So I will make it 1 only. I will not make it 2. So for 7, 3 and 4 also, what is the minimum possible length of subarray I can make from 7, 3, 4? It's 7, only 7. I can make 3, 4, but I need to find minimum. That's why I'm comparing. Okay, so this means from 0 to I. Okay, from 0 to I, the minimum length subarray. And for suffix, it means from I to n minimum length subarray. Okay, So we can we verified that it's from 0 to I only always. We can again change this to make it better. Okay, minimum length of condition for subarray from 0 to j, from 0 to j, and this is starting from j to n. Clear? Any minimum length subarray I could find from j to n, that length will be present. Fine. Okay, let's just go back again to our question. So I have stored this as at answer of 2, and now my answer of 3 would be 7 plus 7, 14. So I'll remove 3, I'll remove 4. Again, my answer of 4 will be what? 1 only. Minimum of all those things, it will be 1. Now we will do the reversing of this. So the reversing of it will be 7, 4, 3, and 7. And now we will find the suffix part. So for suffix, answer of 0 here, so it will be 1 only. Then answer of 1 will be 7 plus 4, 11. So it is greater than. So I'll remove 7. So it came to 4. But this is not possible. Right? 4 is again less than. So we'll compare it with the previous one. 1 comma 1e9 will happen over here and it will be 1. Then answer of 2 will be again 1. Everything will be 1 over here. Okay, the same case as the prefix, and answer of 3 will also be 1. But we need to reverse it because this answer of 1 is for 7 and 4, which are actually 4 and 7 in my original array. So I need to reverse this suffix array. So I will reverse it and it will become 1, 1, 1, 1. And my prefix has also become 1, 1, 1, 1. Okay, now I'll do the summation of this. This one, 2, this one, or this one, 2. Any of which I'm doing, because this example is like this, you will find like this. But you can get different values. Okay, and you need to do the minimum of this. Minimum of two lengths. If I do the addition of both the lengths, that should also be minimum. So I'll do the addition of both. Okay, and I get 2. So which 2? One is this 7 and one is this 7. Both of length 1, 1. So total length is 2. Okay, let's just code it. So we will have this n as array dot size. We will have one prefix, okay, which will be sliding window of passing array and target, and then we'll reverse this. Now we will calculate the suffix of it. After reversing, we will again reverse the suffix array. Cool. Okay, let's just create this. So we'll have one vector of int sliding window. We'll pass our array and our target. I and j needs to be 0, n is array dot size, and our sum needs to be 0, and our answer vector needs to be 1e9 because we need to store the minimum lengths. So we will initialize it with the minimum sum of lengths of the two required subarrays, or we will return -1 if we cannot find any such subarrays. So how we will check for the -1? If prefix of I is 1e9 or suffix of I is 1e9, that means the addition of those could be greater than 1e9. That means one of these is 1e9. So we have found only one subarray or no subarrays with sum equal to target. So there we will we will return the -1. Fine. So while j less than n, we will do our calculation part. We'll follow the template. So just see how we are following. Sum plus equal to area of j. If sum is equal to target, so we are satisfying the condition. If we satisfy the condition, we will check if j minus 1 is greater than equal to 0. If yes, we will do the minimum because we need to store the minimum of this comma j minus I plus 1. Else, we will just replace it. Else, while I less than equal to j and our sum remains greater than k, we need to subtract it from the I part. So we will subtract it from the I part and we will do I plus plus. Now after coming out, there could be two conditions: whether the sum became greater than equal to k or less than k. So for equal to k only, we need to replace it with j minus I plus 1. So if sum has become equal to k, or sorry, target. Okay, we have target here also. Then the same thing we will do. Okay, the same thing we will do, j plus plus. So after coming out, we will check if j minus 1 is greater than equal to 0 and j less than n. So this will update for some less than k also. Some less than k will fall under this else condition. Will not go under while, will not go under if sum equal to target, because sum is less than k. So only j plus plus will be done. Okay. So there we need to replace it with minimum of j minus 1 comma current value. Okay, because answer has been possible in j minus 1, so we need to replace it. This is the beauty of prefix suffix. This is the one of the beauty of it. And this reversing part and calculating prefix and suffix. Cool. So we have got this answer array. We'll return this for sure. Okay, so we'll have this answer, we needs to be as minimum as possible, so we'll initialize it with maximum only. 0 to n minus 1, we'll do minimum of prefix of I plus suffix of I plus 1. If answer is greater than equal to 109, that means we haven't found two non-overlapping subarrays with sum equal to target. So we'll return minus 1, else we will return this answer only. Fine. So there is one more question like this, which is little bit trickier than this. I'll be covering it separately in the next video. Okay, I hope you have got this point clear. I'll be sharing you with the notes of prefix suffix plus sliding window and this question and one extra question like this only, but that question has fixed size, so you will be given two lengths, that the length of the first array could be first length and the length of the second non-overlapping subarray could be second length, or vice versa. First could be second length and for the second subarray it could be first length. Those are the two different lengths which will be given. Some will also be, some might have not been given, but these two lengths are given and you need to find the maximum sum possible or minimum sum. Okay, just go through this, go through that question. It is very easy, like this only, but you need to do this 4 times. You need to apply the sliding window for finding prefix sum both with the first length and second length, because it is fixed size, and for the suffix also both with first and second. So anything could be possible: first subarray with first length and second subarray with second length, or vice versa, first subarray with second length and second subarray with first length. Okay, we need two subarrays and two different lengths which will be given in the question. So just go through that question. I'll be giving you in the description. Go through this question also. These are actually very hard topic. I'll be covering one tricky question in the next video. Stay tuned, stay safe, and if you have learned a lot of out of this, do like, share, and subscribe. Okay, bye.